Guys, and getting ready for lesson 97, some important concepts here we'll kind of go over in the context of this practice. The blank of the equation of a line is y equals mx plus b, where m is the slope of the line and b is the y-intercept. What is that form called?
Slope-intercept form.
Yeah, it's the slope-intercept form, because they give us the slope and the y-intercept. All right? Determine the slope and y-intercept of each of these equations. What is this one? Slope is negative 1/3, and the y-intercept is negative 5. Exactly. The next one is not in slope-intercept form. Does anybody remember how to do it from standard form? Wilson? No?
Oh, negative a over b.
It's negative a over b, so this would be negative 2 over 2, which is negative 1 is our slope. And the y-intercept is c over b, so the y-intercept is 3. So the slope-intercept form of this would be y equals negative 1x plus 3. And you could get that by solving for y, subtracting 2x and then dividing everything by 2. Now, graph each of the following inequalities on a number line. On a number line, what would this one be?
Open circle at 3.
Open circle at 3 and shade to the left, right? And this would be a
Closed circle at
negative 2 and shade to the right. Okay? So that's just a few concepts that are going to come into play in lesson 97. Lesson 97, we are graphing linear inequalities in the coordinate plane.
That sounds fun.
It's not bad, really. It's graphing lines and then going. But there's a few concepts and things that are different here than we've done before. But lesson 97, we're learning to graph linear inequalities in the coordinate plane. What do we mean by coordinate plane? It's the XY plane, right? It's a two-dimensional space. The two problems that we just graphed on the previous screen in the bell work, those were on the real number line, right? That's a one-dimensional space. We're just going one direction or the other direction, right? So it's a one-dimensional object. The coordinate plane is also called the XY plane. The XY plane. All right, so we've got an x-axis and a y-axis, so the coordinate plane is also called the xy plane. Okay, George, question?
No.
All right. Let's try to stay completely on topic here because we've got to make up some time. You don't need to write this. The slope-intercept form of a linear equation is y equals mx plus b, where the value of m is the slope and the line and the value of b is the y-intercept. We just looked at that in the bell work. The slope-intercept form of a linear inequality is y is less than mx plus b, y is greater than mx plus b, greater than or equal to, less than or equal to. Any of the inequality symbols. We could even talk about y is not equal to mx plus b. Okay, that means y and x could be anything except the points that are on that line.
Could they be 0?
Okay, anything except the points on the line. All right. The solution to a system of to a linear inequality, all right, this is important. The solutions, you might want to write this down. The solutions to a linear inequality are ordered pairs that make the inequality true. So if we have an linear inequality like y is less than mx plus b, the solution there is going to be a point that makes that inequality true. Okay? And there are always going to be an infinite number of points that make linear inequalities true. So the solution set will be an entire shaded region of a graph. So the solution to an equation, let's talk about the progression of things. If we're just solving an equation, we get a number as our answer, right? If we're just solving an inequality in a one-dimensional space on the number line, our solution is a whole set, an infinite set of numbers. But if we're solving a linear inequality in two variables, we have a y and an x, our solution is going to be an infinite number of points. So it's going to be an entire shaded region of our graph, and that'll make a little bit more sense as we go through this. But we're looking for points that make the linear inequality true. So let's look at this one. Is 0, 4 a solution to this linear inequality? How do you know, Jackson?
4 is greater than -1.
Because if I put y in for, if I put 4 in for y and I put 0 in for x, I have 4 is greater than -1. That is true. And because it's true, it is a solution to that. But aren't there lots and lots and lots of numbers that would work? Lots of points would fit this solution, right? It happens to be any number or any point, and we're going to get to this, we're getting a little ahead of ourselves, but any point that is above this line, 5x minus 1 will work. And it's above it because of the greater than there. Any point above 5x minus 1, what does 5x minus 1 look like? Has this, right? Any point above that line will make this equation true. So I'll pick a point over here, -6, 6. If I plug that point in, I get -6, no, 6 for y is greater than 5 times -6 minus 1. Well, of course it is. This is -31, right? So any point above that line is going to work. So the shaded region here is going to be the solution. Any point inside that shaded area would be the solution. Now we'll talk a little bit more about the line. Technically this line should be dotted because of it's just greater than, so the line itself is not a solution. If you take a point from the line, like 0, -1, it's not a solution to the equation. If you put -1 into this, you get 5 times 0 minus 1. If you put this point into the line. Is -1 greater than -1? No. It's greater than or equal to. So if we had equal, we can include the line. If we don't have equal, we can't include the line as part of our solution. Yes, Wilson?
And if it was y is less than, would it be below the line?
Below the line, that's exactly right. So we're going to skip this one and move on to the next example. Graph each linear inequality in the xy plane. Y is greater than or equal to -3/4 x minus 3. Okay? Jay?
Would you care if we just shaded the region where the answer could be in for the answer?
Not only would I be okay with that, you have to do that. That's the only way you can express the answer is graphically. This is purely graphical way to show things. All right, so the first thing we want to do is start off by graphing the barrier line. And because it's greater than or equal to the line is included in the solution. The line is our open or closed circle, so to speak. On the number line, we did open and closed circles. We'll do solid or dotted lines here. -3/4 x minus 3 has a y-intercept of -3. And then how do we continue graphing it?
Use the slope.
Use the slope. So we could go down 3 and over 4, up 4, down 3 and over 4. Which way?
To the right.
To the right. So down 3, go down 3 and right 4. Remember, over is not descriptive. Or we could go up 3 and left 4, right? But that's the point of the line that we would get there. So my line's going to look something like this. Okay? Now, because y is above that, y is greater. And if you ever get confused about that, just go to the y-axis. Go to the y-intercept. Y is greater. Which direction is that going to be from this -3? It's up, right? So from there, it's up. So everything above this line is a part of my solution set. Any point above the line and including the line is a part of the solution.
So when we're drawing these, do you want us to dot the line when it's just greater than or
Yeah,
less than?
yeah, and let's look at one of those. All right. Next example. x is less than 4. And we're gonna get another little lesson here, a special case. We've talked about this, we've mentioned it, but we've not really spent a whole lot of time devoted to it. What does x is less than 4 look like just on the number line? Open circle at 4 and shade to the left. So if we're just talking about this on the x-axis, that would be all of these points, right? But we also have all of these points up here where x is less than 4, right? Isn't x less than 4 if I pick this point right there? If I pick this point right there, isn't x less than 4? So it's really all values then that are to the left of that boundary line, x equals 4. And it's dotted because it has to be strictly x is less than 4. Now we've not spent a lot of time doing this. Y'all have got to tune in and pay attention. Okay? X equals 4 is a vertical line through x equals 4. And that's opposite from intuition, isn't it? Because the x-axis is what? Horizontal. Okay? And there's an acrostic that I want you to write down, and I want you to remember this. It'll change your life. We're going to do this quickly. Hoi vux. Okay? Hoi vux. And you can write it side by side. Just give yourself a little bit of room. Hoi is for horizontal. Horizontal lines have a slope of 0 slope. Horizontal lines have the equation y equals just a number. Y equals 2, y equals 5, y equals 7. Horizontal lines. So again, that's counterintuitive because the y-axis is vertical. The y-axis actually has an equation of x equals 0. We already know that because the y-intercept is everywhere that x equals 0. That's the definition of the y-intercept. Now, let's talk about this one here. What's vux going to stand for? We know that vertical lines have undefined slope. We already know that. And their equations are x equals a number. This will help you a lot on the ACT, because there's some questions on the ACT about vertical and horizontal lines. What's the equation of the vertical line that passes through this point? The equation of the vertical line that passes through 2, 3 would be x equals 2. How do I know it's x equals? Vux, vertical, x equals. What's the equation of the horizontal line that passes through 2, 3? Horizontal line's y equals a number, so that would be y equals 3.
But the 5th period world history class needs to bring their atlas to class today and not their textbook. Please bring your atlas and not your textbook to world history, geography.
Okay, we're not going to have a lot of time to work with both of these examples, so let's just do the second one. 3x minus y is less than negative 4. To graph this, what would we do? Subtract 3x from both sides. You've got to be careful here because we got this negative y hanging out. So when we divide through by negative 1, we got to flip the symbol. When you change all the signs, you have to flip the symbol. Sorry, my iPad's not cooperating in that region right there, so that's a 4. Y'all okay with that?
Yes, sir.
Y is greater than 3x plus 4, has a slope of 3 and a y-intercept of 4. So I'm going to intercept right here 4. I'm going to go up 3 and right 1, or I can go down 3 and left 1. Right, so pretty steep line. Go right through there. Now, I'm not going to use that line. Hold on, I think I can go back. Because this line needs to be what? Dotted. I need a dotted line here because I need to do something to show that it cannot equal the line. It's going to be strictly greater than the line. There's no equal sign here, so I've got to dot the line. Which direction is y greater on this line? Up. Right, so I'm going to take all of this area here. Any point in that region will satisfy that inequality. All right, now, let's talk about graphically. Y'all get out your graphing calculators. And while you're doing that, what would the inequality for this be? What's the equation of this line right here?
It is less than.
It's y equals -1, right? That's that line.
Yeah.
Am I above or below it?
Below.
Is the line solid or dotted?
Solid.
So it's y is less than or equal to -1. Some of you tried to do x, right?
Yeah.
How do we know this is a y equals line?
Oh,
Hoy, y equals is horizontal. Okay? What about this one? What's the equation of this line? What's this point right here?
Y is
2,
greater
4,
than-
y equals, the equation of the line is y equals x minus 4.
Yeah.
Because the slope is 1, right?
Yeah.
If we go from this point up to and right to, that's the slope. So 2 over 2 is 1, even though that was 4. All right? So, am I above or below this line? Am I above or below this line? Shaded. It's shaded above, right? So that would be y is greater than x minus 4, and it's not included. Take your calculators out. In your Y1 screen, they're letting out early. I don't know why.
I think the bells are
Yeah, but we're going to finish this problem. They're letting out early. X minus 4. Now, take your cursor and move over to the equal sign. Actually, not the equal sign. Go all the way over to the left, where it probably just has that for now. And you want to hit your up and down arrows on that symbol until you come to something that looks like this. What is that telling you to do? It's telling you to shade above that line. No, I'm sorry. It'll look the opposite of that.
It's not working.
It should look like that.
Like, all it's doing is just going up and down.
Yeah, it's just moving it up and down.
Do you have your, maybe hit enter then. If you hit enter, it'll change it. Sit down, Jay. Sit down. That's on the video, by the way. Yeah, you want it to, the triangle to look like this.
And I believe it's shaded
And if you do that, it's going to shade it above, I believe.
Yep. So,
Yeah.
yeah.
All right. So everybody look at Haley's calculator here. She's got it right. Okay. It'll actually shade the regions for you. Your homework is,
It gives me all the different types of lines, and it has two different.
well, you haven't put anything in. That's greater than. See how that looks greater?
Oh, okay. That makes
So
more
if you
sense.
go x minus 4 here, the graph, it shows you what
That
we
is
did.
very cool.
Yeah. Y'all have a good day. Sorry we ran over.